Welcome back. So we're going to be using linear equations to solve problems. Bathtub problem. You pull out the plug from the bathtub. After 40 seconds, there are 13 gallons of water left in the tub. 1 minute after you pull the plug, there are 10 gallons left. Assume gallons varies linearly with the time since the plug was pulled. Right? So that, oops, come on. Isn't one underline? It takes 3 tries. That was 3. There we go. So linearly, we already know this is a linear function. Right? So we have to identify points and the slope. Before you do any of those things, you need to figure out with a real-world problem which variable is x and which is y. So the dependent variable is always y. The independent variable is always x. The question itself tells you which is y, which is the dependent, and which is x, which is the independent. It says gallons varies linearly with time. It's another way of saying, so if we see something like gallons varies linearly with time, that means that gallons is the dependent variable. It depends, it varies linearly. It depends upon, it changes as, any way you want to think of it, time. That's going to be the independent variable. Very important you identify those correctly, otherwise your slope is going to be reversed. Your points are going to be reversed, and certainly your equation is not going to be correct. And any answers you find with that equation are also not going to be correct. So our dependent variable is gallons. So it's gallons specifically of water. And then the independent variable is time. And we should identify the units of time. So it says after 40 seconds, right? 10 seconds, whatever. No, it just says 40 seconds. That would be time, and that's in seconds. Right, so make sure you have your units there so you can interpret your answer. We want to write the particular equation expressing the number of gallons left in the tub in terms of the number of seconds since you pulled the plug. And this is in your notes. But in fact, you have a whole page for this problem. All right, so let's find our slope. Not identify, find our slope. All right, actually, before we find our slope, I take that back. Let's identify our points. All right, we know which is the dependent and which is the independent. Now we need to find, actually find points that match that. Right? So the first thing we have to do is figure out who is independent, who is dependent. The second thing we have to do is identify the points. That's supposed to be a T. Identify. Make sure you write them correctly. Right? X goes first, then Y. So time is going to go first. Right? So after 40 seconds, that's the X, there are 13 gallons of water left. Anybody want to underline that? 40 seconds, 13 gallons. So 40, 13. And 1 minute after you pull the plug, there are 10 gallons left. Make sure you don't write 1, 10. Right? That 1 isn't representing a second, it's representing a minute. And a minute is 60 seconds. You have to make sure those units match. Right? So let's put that there. Match units. Right? It's no good to write 1. So 60, 10. All right, now that we have points, let's find the slope. Right, so our slope is going to be 10 minus 13, change in y over change in x, 60 minus 40. And that's going to give us negative 3/20. And that is not going to reduce. That's our slope. All right, so now we're asked to, now that we've got slope, we want to write the equation for that. It does not say, so it says write the equation. Notice it does not say you have to write it in slope-intercept. You can write it in slope-intercept, you can write it in point-slope, right? Or you can start with point-slope and change it to slope-intercept. Right? Any of those would be correct. Right? We're not going to be able to write directly with a question like this into standard anyway. And actually, we can't write directly into slope-intercept form because we don't know how much water was in the bathtub. Let's just write the equation, right, in point-slope form here. So our next step is to write the equation in point-slope form. It doesn't matter which point you use. Either of them is fine. Let's use the 60-10, I guess. All right, so we have y minus, yeah, actually, no, I'll use the first one. I'll use the 40-13. Y minus 13 equals negative 3/20 x minus 40. Numbers are just a little, the x value is just a little smaller. But either of them would have been correct. So you could have wrote this one, or, let's write them both. What the heck? Let's write them both. Y minus 10 equals negative 3/20 x minus 60. All right, so either of them is fine. Let's just leave it in terms of point slope since we weren't told to simplify it to slope-intercept. Now let's look at question B. Says, find the y-intercept, the gallon-intercept. Well, gallon, y is referring to gallons, right? This is a real-world problem, right? So when we're finding the y-intercept, we're finding the gallon-intercept. And what does this number represent in the real world? So to find our y-intercept, or gallon-intercept, let's rewrite the equation in slope-intercept form. If we rewrite it in slope-intercept form, we'll know what the y-intercept is. All right, so I'll just use the first one. Y minus 13 equals negative 3/20 x minus 40. We're going to distribute the negative 3/20 to both sides. Y minus 13 equals negative 3/20 x. All right, so now if you're not sure how to multiply that, looking for a space here, I'm just going to squeeze it in over here. Negative 3/20 times negative 40. That'd be over 1. And we could reduce. You can cross-reduce. You can reduce within a fraction, or you can cross-reduce. So 20 goes into 20 one time. 20 goes into 40 two times. So that's going to be negative 3 times negative 2. That's 6. So nice, easy number there, plus 6. And then to isolate, we're going to add 13 to both sides. All right, so our equation is going to be y equals negative 3/20 x plus 19. And what does that represent in terms of our bathroom problem here? Right, so the y-intercept tells you the value of y when x is 0. In other words, no time has gone by. So when no time has gone by, let's write that in. When no time has gone by, let's put elapsed. That's a nicer way to say has gone by. There are 19 gallons. Whoops. I hit that way too many times. I'm going to just go back just so that I can get the page the right size again. There we go. No, it's going to happen again, huh? 19 gallons of water in the tank. I'm bound to hit that extend to page. All right, so that's what that y-intercept means. It tells us how much water is in the tank before any time goes by. right? So there was 19 gallons. That's our y-intercept. So now we're going to find the x-intercept, the time-intercept. We could use either equation. We could use the point slope or we could use the slope-intercept form. Doesn't matter. I think it would be easier to use the slope-intercept form right now since we have it. And to find the x-intercept, we're going to set y equal to 0 in any of the equations. It doesn't matter. And solve for x. Right? So now we're doing the reverse. So now we're finding the value of x when y is 0. So we would have, if we use y equals negative 3/20 x plus 19, we plug in 0 for y. We have 0 equals negative 3/20 x plus 19. Right? So we're going to subtract 19 from both sides. So negative 19 equals negative 3/20 x. And we want to get x by itself. So if you have a fraction in front as a coefficient, just multiply by the reciprocal. So negative 20/3. So we're going to multiply both sides by negative 20/3. That's not going to simplify. So we're just going to multiply. So negative 20 times negative 19, that's going to give us a positive 380 thirds equals x. Right, so x is referring to time. So we set y equal to 0. What's y referring to? Well, y is the number of gallons of water in the tank. So it takes 380 thirds, or that's approximately 126.6. Did that in my head. Let's make sure I didn't make any mistakes. Yeah, I think that's right. Seconds for there to be no water in the tank. I need a little bit more space. Now I am going to have to hit extend the page. No water in the tank. I think my writing's a little crammed in here. Hopefully you can read it okay. All right, so the y-intercept tells us how much, when no time has gone by, how much water is in the tank. The x-intercept tells us how long it takes for there to be no water in the did I say tank? This is a bathtub. I've turned my tub into a tank. I don't know who would take a bath in a tank. Tub. There we go. All right, so we found the x-intercept. We've written the equation. We found the x and y-intercepts and interpreted those. And now we're going to be graphing. There might be another question on the next page. And we're going to have to, when we're graphing, we have to remember our points. So I may have to go back to this page to remember my points. The graphing is the only thing we have left. All right, so we need a reasonable scale. Let's see, the largest value on the x-axis is going to be, now negative numbers aren't going to make any sense, right? We're not going to have negative time and we're not going to have negative water in the tub. All right, so we're only going to be dealing with the first quadrant. The largest x value is approximately 126.6. All right, so let's see how many spaces we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. How about we go up by 20? All right, that'll make it easy. So this, and I'm going to skip every other just so my numbers aren't crowded. So this would be 40, this would be 80, this would be 120, this would be, I've lost track, 200, wait. We're adding 40. 160, 200, 240, 280 is more I need now. More than I need right now, but that's okay. 320. All right, so now remember there were 19 gallons in the tank. So 1, 2, 3, 4, 5, 6, in the tub. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16, 17, 18. Oh, look at that, just fits. All right, so, and I'm going to count by twos. All right, so this would be 2, 4, and you can do the same thing, 6, 8. I like to give myself as much space as possible. And I don't like to, have to redo things, so I try to figure out the scale first. 10, 12, 14, 16, 18. So that's going to be 19 at the very top line there. All right, so let's graph our points. I remember we had the point 0, 19. I'll write them all down. We had 0, 19. We had, was it 126.60? There was, I think, 40 something. 40, 13, and 60, 10. Right? So use your x and y intercepts and use any points you're given. So we were given the 40, 13 and the 60, 10. We should use all of our points. All right, so now we're going to graph those. So 0, 19, 40, 13, so that's going to be 40 on the x, 13 on the y, 60 on the x, 10 on the y, and then 126.60. So now we're going to have to estimate that a little bit. So it's this line right here. That's 140. All right, so we're going to be a lot closer to the 120 than we are going to be to that 160. So if each line here is 20, 10 would be halfway. It's a little bit, just about a third, just about there. All right, so now we're going to connect those points. You use a ruler, I'll use a line tool, and we'll all be done. Do I have a, oh, I do. I'm waiting for nothing. All right, so now this time, when I fix my line, I am not going to put arrows on this line, right? Because we're not going to all of a sudden get more time, negative time, right? And we're not going to get any more, 19 gallons, that's it, right? We had the tank, the tub filled. I keep wanting to call it a tank. The tub filled, we pulled the plug, we emptied the tub. So that's it, right? Let's write our domain and range. So now this is a restricted domain and range because it has to match the word problem. The graph is going to be of great help here, right? So our domain, remember domain is x, it's our input, all right? So after 126.6 seconds, right, we run out of water in the tank, right? There's no more water to put in the tank. No, there's, the water's out of the tub, right? It's empty, right? Time stopped, right? So in terms of this problem, 0 time goes by, right? We have water in the tub, and then I'm going to write the exact answer rather than the decimal approximation. 380 thirds. So 0 to 380 thirds, that's our domain because that's all that makes sense for this problem. And we're going to use brackets, right? Because both of those numbers are included in domain. Right? This is our starting time, if you will. And this is our ending time. Right? So now we have y, which is our range. That's the water in the tank. Right? When we start off, right, we have 19 gallons, and then all the water drains out. Right? So in this case, the ending time, or the ending amount, is 0 gallons in the tank. The starting amount was 19 gallons in the tank. But when we write domain and range, we go from the least to the greatest. So our range is going to be 0 to 19. Right? We're not going to have less than that. in terms of water in the tub. We're not going to have more than that. That's it. Right? And so this is the end of this problem. Now, except for one thing that we did not do, and that is you really need to, on a real world problem, label your axes and what they stand for. So this is time in seconds, and this is water in the tub, and that's in gallons. Right? Label those X and Y axes on real world problems. All right, well, thanks for watching, and I hope you've learned a lot. Bye for now.